Hello everyone. In this video I will be working on two subsections. The first section is data input and output, simply how to extract the data from certain data formats like CSV, Excel, HTML, and so on and so forth. And then the second thing, how to output them, how to output such files. All right, that's what it is. So regardless, we're starting with importing these pandas and NumPy. And then the next thing is I'm going to read the data from my computer, right, into the Python environment, into my notebook environment. So the script that I'm using here is that, as you see, PD pandas, that means pandas, right? You know, for the NP cases, NumPys, we're always starting with NP, and for panda, we're always starting with PD. PD.read underscore CSV is a built-in function. Okay, so what it does is it calls the data sets from outside, okay, which in this case it's the California salaries data. But one thing that I should note, if you want to pull a data set to your notebook environment, that data set has to be in the same directory where your notebook is. In this case, I mean, in your case, maybe if your notebook, the one that you're currently using, is on the desktop, then your data set should be saved on the desktop as well. Okay, so that's what it's supposed to be. And after reading that data, I'm going to, assign it a variable, which I'm going to call it salaries1 to make my thing simple. And look what happens. Now it pulled the data, which consists of 100 rows and 13 columns. I've got 100 rows and 13 columns here. That's what I'm pulling. Okay, so for your reference in the future, what you will do is, if you're calling a data from outside, you would always start with pd.read. I'm telling Python, be careful. I'm trying to read a data file from outside, which is supposed to be at a certain directory. Okay, so that's what I'm telling. But Python doesn't know what data I'm calling, or if I don't remember, let's say if I don't know the format, if I don't know very, very specific things about the format of data, what I can do is I can hit tab, and what it will give me is that, okay, Python is basically telling me what kind of format are you going to try to pull in, like what is the format of the data that you're trying to pull in. So in this case it's CSV. For some other case it could be Excel, it could be other things. So but for your reference, if you just don't know what the format of your data, read underscore, hit tab, and that will give you the quick options, right? And for you, if you want to learn, it is not related with what we do right now, but the pwd function, what it does is that it basically tells you what directory are you in now, what directory is your notebook at. Okay, for me, for example, users, that's my username, create a username, desktop, teaching, teaching is a folder, Spring 2020 is another folder, advanced machine learning class with Python, and under that folder I've got the folder called module 5. Okay, so basically this notebook that I'm currently recording now was under the module 5. All right, so therefore the data has to be in that file as well. All right, that's what I'm trying to say. So whatever the data that I'm saving, it has to be in that file. Okay, so now I've learned where my data is supposed to be. Now I'm done with the CSV file. I've just basically read it. Okay, and then this is what it looks like. I'm going to do the same exact thing for Excel. This time it's again pd.read. Instead of CSV, I've got Excel, the exact name of the Excel, and then the same data set. I've got both the CSV and the XLSX version of the same data file in my directory. I've got those two files already stored in the same directory. So that's why I will be able to pull that up. But now I'm going to call it salaries2, and if I call the salaries2, now it's the same exact data that I just pulled from there. This one was from CSV, this is from XLSX, the Excel file. Okay, so the next thing that I'm going to do is, regardless of what thing that I have used in the past, it could be Excel or CSV, now I've got my data in salaries2. Let's do our operations with the salaries2, the one that I can see here. Okay, as you can see, I've got 13 columns here and 100 rows. I've got some categorical variables, some continuous variable, and so on and so forth. So what I want to do is I'm going to tell data, can you give me by using the head function. Okay, basically I'm telling the data, can you give me the head of the data? That means the first 5 rows. Okay, as you can see, 0, 1, 2, 3, 4. Okay, the first 5 index. So basically the goal of using that such function is for you to see what is going on, in your data. What does it look like? Okay, instead of seeing the whole data, which is 100 cases, which you cannot see, right? It's impossible. Therefore, you just want to just see your data. Okay, and the next function is called columns. Okay, salaries.columns, and basically it will tell you what columns do you have in your data. Okay, you've got the ID column, employee name, job title, and so on and so forth. You've got 13 columns here. Okay, the next quick function that we use is describe, and you are familiar with the describe function. As you know, it's basically describing the data. Whatever the descriptive statistics about my each column, it will provide me those numbers and statistics, right? Count, mean, standard deviation, and so on and so forth, right? And now let me just call the data again, the head, salaries to that head. So this my data, this is how my data looks like, right? Now I'm going to output. So far I have done the input for CSV and the Excel. Now I'm going to output that data, okay? Let's say my salaries 3 data, I'm going to create a new variable, and I'm going to create that new variable by using salaries 2 data, but I want to drop the status variable from here, okay? The status variable column. That means, where is that? Status is the very last one, and it has a lot of missing values regardless. So let me get rid of that, and whatever the version that I will be left with, I'm going to call it salaries 3. Okay, so as you see in the salaries 3, you don't have the status, you have 12 of those, 100 rows by 12 columns, right? So what I will do now, I mean, the only reason that I'm doing it, I just wanted to use the different data sets. That's it, all right? So the salaries 3, what I will do is I'm going to get that number, get that variable, which is the salaries 3. This is my new data set, the updated data set, right? I'm going to export it to a CSV, okay, which I'll start with .to underscore CSV, and whatever the data that I want to name it, right? I mean, whatever the name that I'm going to name it. So from now on, I want to call it salaries 3, okay, .csv. And then I'm going to provide an index as well. If you're not providing an index, just say, you don't have to do anything actually. If you're not including this here, that means it's, the index will not be provided. But if you put the index, it will be providing the index as well. I will explain what it means in a moment, okay? So if I just give if I do this, what it will do is it will create a data set in my directory, okay, in the directory that I am working in now, all right? And the name of the data set will be salaries3.csv, and it will have no index in it. That means whatever I see here, okay, I'm going to see that only. I'm not going to see extra index, all right? So now I've created that thing here, and let me check if maybe what we can do is, sorry. So let me go to this. Let me go to desktop, and let me go to my teaching, Spring 2020 Advanced Machine Learning. All right. And then module 5, and then as you can see, I've got the California salaries, the XLSX CSV that I just pulled a couple minutes ago. Now this is the file that I just created. If you want to open it, remember I have not given any indexing, so you're not seeing any indexing here. There's ID variable, employees, whatever the variable that I had before, I'm going to see the same exact variables. Okay, let's just close it and go back to our thing again. So now let me just do it in a way that I am, okay, creating an index now. So what it will do is it'll override a new file, salaries 3 will be overwritten on the file that I have just seen, okay? But now it's going to provide an index as well. So the new data set that I'm going to see that I just created, see, that is the file that I just created, and then it has overwritten on it. So as you see, you're seeing the index here. It's not the ID variable that I'm talking about. It's the index that you see on the very left. Okay. So now what I will do is just to check back. I'm going to, I just exported to a CSV in that location. with an index. Now I'm going to read that CSV file. Okay, I'm basically, making a confirmation for myself. That's it. As you see, I've got the index as well. Previously, I did not have any index and I did not have this column, but now I've got this column, unnamed 0, 0, 1, 2, 3, and so on and so forth. This is the index that I had created in that Excel file or CSV file. But let me just go back and fix it because I don't want to have this, right? The indexing. So therefore, let me just rerun this so that I can get rid of that indexing. All right. So what about Excel output? The same exact thing. Again, indexing works the same way. Salary is 3. Now again, I want to, whatever the variable that I created, that I called, right? I called it salaries 3. And I want to export it to Excel now, not the CSV. And I want to call it salaries 3 XLSX. And now I want to provide a sheet name as well. Because, when you're creating Excel, you have to provide the sheet name as well. If you don't provide a sheet name, I'm assuming that it will call it sheet 1 and sheet 2, whatever the default names of those. But it's just an assumption. That's what, intuitively think. And then index, false again, I don't want to provide any index. Let's just create this Excel folder that we think. Okay, let's go back and check it. Okay, now see salaries 3 XLSX data. And if you check it in, there is no indexing in it. So we're good. All right. So now what I will do is I'm going to come back here and read the same data. All right. And when you read it, this is the same exact data set that I've just used, right? I called it salaries 3, which again, the very last column is not existing because I had dropped it. Okay, so that's what it is about this, exporting, importing. Let me come back and delete these. Okay, and let me delete that as well. All right, since I've just created them. Okay, so let's go to HTML data sets. HTML is basically you're scraping the data from websites. You're pulling the data from websites, and basically these are the libraries that you might want to use for the future, just in case. The first 3 of them, LXML, HTML5lib, and Beautiful Soup. Sometimes, there is a new version. It's called Beautiful Soup 4. But anyway, the very original name of that library was Beautiful Soup. Okay. So the first 3 that you see here, those are related with HTML or XML files. Okay. So whenever you're about to scrape something from the websites, these are the 3 libraries that you want to use. Okay, so what I would do is I would just go to terminal for those who have Macs, and then command prompt for those who have PCs. Okay, and then so what I would like you to do is just on your terminal, on your screen, or on your command prompt, just say conda install lxml, or this one. I mean, I would suggest to install all of these 3, okay, regardless, because they have some common points and differences as well. Just to be on the safe side, I would suggest to write this script one by one. Okay, conda install lxml and enter, and then do the same thing for the second line, do the same thing for the third line. And the last one is related with the databases. Okay, the relational databases, that's why it starts with SQL Alchemy. Okay, this is the package that you want to use to pull those databases into your Python environment. Okay, but I'm assuming for the Conda, we are using Anaconda environment, and a lot of packages and libraries are already in. Even if you do not install one of these 3, you might be safe as well, when it comes to reading files from HTML. All right, so what I'm going to do now is I'm going to pull the data from a web page. The web page is this. Let me just open this. Okay, Scholar. This is the Google Scholar page that that belongs to me. Okay, so this is my Google Scholar page. Basically, what you can see about a professor here is that how many publications has he or she done in the last couple of years, and what journals have published this person's publications, and so on and so forth. So how many citations did he get in the last few years, and what was the trend, and what about the co-authors that he worked with, and so on and so forth. Okay, so what I'm going to do is I'm basically copying the name of this website, okay, and I'm pasting it here. Okay, That's it. That's what I'm doing. All right. So once I do this, again, it started with pd panda.read.html this time, not CSV, not XLSX, HTML. And then now I want to call it dag scholar, dag and scholar. And then now once I hit it, it will basically summarize what you got there. Okay. The citations, the H index, the I index, and so on and so forth. Okay. And the titles of those studies, and like what year was that were they published in. Basically whatever you are seeing here, it's kind of summarizing in the format of Python. All right. So the very frequent thing that we will be using is that, okay, I mean, this part might be a little challenging to tell, but basically it's got multiple data structures here, multiple tables in this web page. Okay. So what we want to do is, if you're familiar with the SQL environment, what it does is it searches for data, for those data sets one by one. Okay. So for our case, what it will be is, I've got a notification here from Alex. So what it will do is, it will pull the very first data in here. Okay. So whatever the very first data set, the table that our Python script will hit to, it will pull that data. Okay. So basically what you can see here, whatever the first, okay, table, as you can see, the first table that it reads from the web page is this guy. Okay. So basically I want to call it dag scholar dot, the index of that is 0. Okay. So this is what I will have. All right. And now I can go ahead and create. Remember, I don't have such thing here. As you see, I don't have any, file called dag scholar. So what I'm going to do is, I'm going to use this dag scholar 0, which I just created. Okay. And I'm going to migrate it to Excel file. Okay. Basically, I'm going to export it to an Excel file, and I'm going to call it dag scholar XLSX. Okay. And I'm going to provide a sheet name as well, and the index will be false. Okay. Let's see what happens. Once I hit it, it should go ahead and create one here. And as you see, it's called dag scholar. And if you open that file, you'll be seeing whatever the file that it's just created. Okay. So basically that's what I had got on that screen, right? All right. So this is simply it. Let's just close it and go back to our own business. All right. And then if I want to have some information, some basic information about data set, that's the function that I'm going to be used. Basically .info, open and close parentheses. Okay. And then it will tell me like how many rows did I have, how many records, what and what not. So basic information about my data set. All right. This is about it when it comes to pulling and exporting data sets from CSV, XLSX, and HTML file. And I'm not going to, do anything for the SQL databases. All right. Because it's got some, complicated things in it. So at this point, I'm not going to touch it. But if we will have some time left during the second part of the class, I will definitely hit to that part as well. Okay. But at this point, we will mostly be working with either CSV files or XLSX files, and this much is enough for us at this point. Okay. Let's go to operations part. Basically, again, I'm importing that PD, right? And here what I'm doing is I'm creating a table called df. And I'm using that PD again, data frame. And then what I'm creating is I'm creating 4 students, and I want to call them 1, 2, 3, 4, right? And I have their ages and the majors, okay? And what I'm doing is, okay, give me the heads. But for this case, since I've got 4 of them only, it really doesn't matter if I say df or df head anyway. But if I had more than 5, if I had 6 or 7 or 10, and if I had hit df.head, it would still give me only 5 of those. Okay, the first 5 records. Remember, head function will provide you the first 5 records. Okay, so if I want to get the unique values about a certain column, let's say I've got this df, right, this data frame that I've called, and I'm going to consider the age column, and in the age column I wonder about what are the unique things, unique numbers, right? Here you see 19, 20, 21, 21. So what the unique numbers that I have is 19, 20, and 21. The second function that I'm going to use is nUnique. .nUnique basically will give me how many unique numbers or unique, items that I have. Basically, I had 3 of them. Whatever I had here, it's going to give me however many of them I had. Okay, and then the next, function that is commonly used, again, value counts. Basically, it will tell us, like, each of those unique things will happen certain times, right? Basically, it will tell us how many times of those each unique values occur or exist in that data set. So 21 was happening 2 times, and then the others are 1 and 1 each. Okay. So the next thing is that using conditional selection. So if I want to basically select the ones, okay, you know what? Let me do this. Let me just refresh my data. Okay, and now among these I want to go with the ones that are whose ages are above 20, basically the very last two rows, right? And then now in this case, again, whatever we had done before, I think you guys might be remembering it. I want to go with the ones whose ages are above 20 and whose major is marketing, okay, accounting, BIA, finance and marketing. I want to go with those marketing people who are above 20, and it will give me only one option, one row, which is the very last row. Okay, so now creating functions within the within this operations subtopic. Okay, so let us assume that we're creating a function, we're defining a function that's called times 2, and that, what it does is that whatever the number that I've got, it multiplies it by 2. Okay, so if I have times in parentheses 5, right, let's say if I had times 5, it would just give me 10. Sorry, times 2, 5. It would just give me 10, right? So what I will do is I want to take the advantage of that here in my, operations. So basically what I'm doing is, okay, consider the df, okay, like this, okay, and even let me just put it here. And consider the df data set, okay, that data frame. And now what I'm telling Python is, Python, can you apply that function? So if we are about to apply a function whose name is times 2, right? Basically, I'm telling Python, can you go back to h column and apply times 2 function? Okay, so what it will do is it will just multiply those numbers by 2, and it will provide us that. Okay, and simply what I again can tell Python, can you go back to h column and sum them up with the sum function? Again, let me call my df again, and now I'm working on the built-in functions. Okay, remember the one that I created was a customized function that I myself created. Here I'm going to use the built-in function. Okay, one of those built-in functions are length function. So basically I'm telling Python, can you go to measure, and then can you get me what are the lengths of those? Okay, so accounting has 3 letters, BI has 3 letters, and so on and so forth. Okay, so again, here I'm going to the age and then apply lambda. Okay, lambda x is basically a built-in thing in Python as well. So what I'm trying to say here, Python, I'm going to use a function here, but I'm going to use it one time. All right. So basically, what I will do here is that, Python, can you go to the age, okay, and apply the function. At this moment, I'm going to call it lambda, but it's an anonymous function, okay? And what it does is that it multiplies the number, that x number, by 2, okay? So basically, can you apply this function, the function that I'm creating momentarily at that moment, okay? Can you apply that understanding to the age? That's, what it is, all right? Or what you can do with the lambda function again is, lambda x, again, can you apply the times 2 concept? Times 2 function that I created. Remember, it was the function that I created here, right? Times 2. So basically, lambda, the anonymous function, you can use it, here without using any function name, or you can use it with using the function that you just created. All right? So basically, lambda x means, okay, Python, I'm about to use a function. For this one, it's very simple, x times 2. And for this one, whatever the function that I created, can you apply that? Okay, basically it will give the same exact result. All right, so if you're wondering about, again, let's go back and say df here. All right, if you're wondering about the df columns, okay, so what columns do you have? okay, df dot columns. If you were wondering about the index, so you know how many where is it starting from, where is it stopping at, and what is the step size. So basically indexing is starting 0 and stopping at 4. And remember, in Python, if it's stopping at 4, that means it really has stopped at 3. The 3 was the very last index number that it has used, right? And step is, you know, one, we're increasing one by one. Okay, so let's say we want to drop age from axis 1. And again, if you want to temporarily do it, you can leave it blank. In place is false by default. But if you want to do it not temporarily, okay, but permanently, what you can do is you can copy and paste here. Okay, copy this and paste it here. Okay, and say true. Okay, so what this will do is that from now on your df will change. Okay, whatever it will do it for place true. After that, oh, okay, so we had already dropped. Okay, df is this. Since we had already dropped it here, okay, so the df looks like this. Okay, so what it will do is it's not seeing any, you know, column called age anymore. That's why it's giving an error to us. So age is not found, as I say. Okay, so whatever, let's just go back. I had assumed that I had not dropped it. If I do this, it's going to drop the age. Okay, not temporarily but permanently. All right, again, if you want to sort the values for age, again, it will not find the age because age is not there anymore since I had permanently done it, right? Therefore, but if it was to find the age, what it will do is it will just sort the values from max to min. That's what it should be, or from min to max. All right, so and then is null, that function is the function that will tell you, okay, if there is any missing values in the data. Okay, but basically what you're telling Python is that, Python, can you tell me column by column whether there, you know, whether that specific cell has an NA or missing value in it or not. So false means there is no null or there is no NA in any of them. So is null function basically telling you, you know, if your data is consisting of NA values or missing values. Okay, that's it.